Hello everyone, my name is Ayush Verma and today we will discuss about understanding queues and its sequential representation. So we will discuss about understanding queues and data structure and what is FIFO, then operation of queues, then types of queues like circular, dequeue, priority queues. Then we will talk about introduction to sequential representation, then difference between stack and queues, then application about queues in real life. So let's get started. Understanding the queue's data structure. Queues basic. A queue is a linear data structure that follows the first in, first out principle. Elements are added at the back and removed from the front, similar to a line of people's waiting. Then characteristics. Queues are characterized by their order of processing, where the first element added is the first to be removed. They are commonly implemented using array or linked list, provided efficient access to the front and back elements. Examples. Common examples of queues including waiting lines at the store or ticket counter. In computing, task scheduling is operating system often utilizes queues to manage processes efficiently. Then, what is FIFO? FIFO is nothing but first in, first out. FIFO is a principle that ensures the first element added to the queues is the first element to be removed. Then, operation of queues. There are five operations that queue executes. That's Enqueue, Dequeue, is empty, is full, and front and rear. So, Enqueue is nothing but add an element to the rear end of the queue, such as if queue is 1, 2, 3, and your Enqueue 4. The queue becomes 1, 2, 3, and 4. Dequeue. Dequeue is nothing but remove and return the front element to the queue. Example, if the queue is 1, 2, 3, and dequeue will return 1 and the queue will becomes 2 and 3. Is empty is check if the queue is empty. If the queue is empty, then it will return true, otherwise false. Is full. Check if the queue has reached its maximum size. If the queue is full, then it will return true, otherwise false. What is front and rear? Front, return without removing the element from the queue. And what rear is, return the last element in the queue. Example, in 1, 2, 3, the rear is 3 and the front is 1. So, enqueue operation. Algorithm, its enqueue int element handles insertion. Second point, it checks for overflow. If rear equals to maximum size minus 1. If queue is empty, then front will be minus 1. It initializes front to 0. It increments rear and places the new element at that position. There shows a program where we first void it, insert, and then take local variable items. If rear equals to max minus 1 means if the value of rear is maximum, then it will print queue is overflow. Else, if front equals to minus 1, that means front equals to 0, it prints the element to be inserted. Then it will scan that element that you want to be inserted. Then the rear will be rear plus 1. Then queue of rear equals to items. Then we will see dequeue, queue, and displaying operation. In deleting an item from queue, void delete, and there was a condition, if condition, like if front equals to minus 1 or front is greater than rear, then it will print queue is overflow. Else, print element deleted from queue, then front equals to front plus 1. And for displaying elements, void display where we take local variable I. We take local variable and a new element I. If front equals to minus 1 or front is greater than rear, print q is empty, else print q is, and then we run for loop like I equals to front, I is less than equals to rear, and then I plus plus, print q, and then types of queue. There are four types of queue: simple queue, circular queue, priority queue, and double-ended queue. Simple queue is a queue in which insertion occurs at the rear end and deletion occurs at the front end. And in simple queue, we will also call it as linear queue. Circular queue. A circular queue is a queue in which all nodes are treated as circular, such that the last node follows the first node. In priority queue, a priority queue is a type of queue that arranges elements based on their priority levels. When we add an item, it is inserted in a position based on its priority. Elements with higher priority are basically retrieved or removed before elements with lower priority. Double-ended queue. Dequeue or double-ended queue is a queue in which insertion and removal will be performed from front or the back or rear end. So, circular queues. The arrangement of elements Q0, Q1 to Qn in a circular fashion with Q1 following Qn is called circular queue. The last node is connected to first node to make a circle. Initially, both front and rear pointers points to the beginning of the array. It is also known as ring buffer. So if rear plus 1 equals to 5, that means it's overflow. And if rear equals to rear 1 plus 1 modular 5 equals to 0, then we will start the queue. Operations. There are two pointers, front and rear. The front track the first element of the queue, the rear track the last element of the queue. Initially, set the value of front and rear to be -1. There were two operations like enqueue operations and dequeue operation. In enqueue operation, check the queue is full. For the first time, set value of the front to 0. Then circularly increase the rear index by 1. Then add the new element in the position pointer to by rear. However, check the full queue has a new additional element. Case 1, front equals to 0 and rear equals to maximum. And case 2, front equals to rear. And case 3, front equals to 0 and rear equals to size minus 1, which means that front is at the first position of the queue and rear is at the last position of the queue. Then front equals to rear plus 1. In dequeue, check if the queue is empty. Then return the value pointed by front and circularly increase the front index by. For the last element, reset the value of front and rear to -1. So now what is priority queue? A priority queue is a type of queue that arranges elements based on their priority values. Each element has a priority associated when we add an item. It is inserted in option based on its priority. There are two types of priority queues, an ascending priority queue and descending priority queues. An ascending priority queue is a collection of items into which items can be inserted, discretion, and from which only the smallest item can be removed. In queue operation, add an element to the rand end of the heap. Restore the heap properties by the comparing the added elements with its parents. If it can violates the heap property, swap them. Continues this process up the heap until the correct position is found or root is reached. Dequeue operation. Replace the root of heap with the last element in the heap. Reduce the size of the heap by 1. Then restore the heap properties by the executionally comparing the new root with its children and swapping it with the higher priority child in the maxed heap or the lower priority child in the minimum heap. Continues this process down the heap until the correct position is found or the leaf is reached. Then double-ended queue. A double-ended queue or DQ is a linear data structure where element can be added or removed from both the front and the rear. It is an extension of the standard queue, which only allows insertion at the rear and deletion at the front. This flexibility makes DQ useful in scenarios where you need to efficiently manage collection with dynamic size and acquire access of both ends, such as in palindrome checking or task scheduling. There are two types of dequeue: input restricted dequeue and output restricted dequeue. In input restricted dequeue, the data can be inserted from only one end while it can be deleted from both the ends. In output restricted dequeue, the data can be inserted from one end from only one end and while it can be inserted from both the ends. Insertion from front end. With the help of insertion at the front end operation, we can insert the element from the front end of the dequeue in data structure. There is a criteria before implementing the operation. At first, we need to check whether the dequeue is full or not. If the dequeue is not full, then we can insert element from front end by the following the below conditions. Initially, we will check the position of the front variable in our array. In case the front variable is less than 1, we will reinitialize the front as the last index of the array, front equals to n minus 1. Otherwise, we will decrease the front by 1. Add the new key, for example 5, here into our array at the index front, array of front. Every time we insert a new element inside the dequeue, the size increases 0 by 1. Then deletion of the rear end. With the help of the deletion at the rear end operations, we can delete the element from the rear end of the dequeue in data structure. We can delete the element from the rear end by the following condition. At first, we need to check whether the dequeue data structure is empty or not. If the dequeue data structure is empty, that is front equals to minus 1, we cannot perform deletion process and it will throw an error of underflow conditions. If the dequeue data structure contain only one element, that is front equals to rear, set front equals to minus 1 and rear equals to minus 1. Else, if the rear is at starting index or the dequeue, that is rear equals to 0, point the rear to the last index of the dequeue data structure, that is rear equals to n minus 1. If none of the cases satisfy, we simply decrement our rear by 1. Rear equals to rear minus 1. Every time we delete any element from the dequeue, the size is decreased by 1. So, now we'll discuss about sequential representation. A sequential queue representation utilizes an array in 1D to store elements with pointers front and rear, making the start and end of the queue. This method is suitable for fixed queue, offering simplicity and efficiency in certain scenarios. So, there are four types of, or we can call it like representation of queues: array implementation, indexing techniques, overflow handling, and memory optimizations. In array implementation, uses array to implement queues for efficient element access. In indexing techniques, use indexing to quickly find the front and rear of the queue. Overflow handling. Handle overflow by resizing the array or using a circular queue. So, let's talk about difference between queues and stacks. In queues, linear data structure follows FIFO principle, but in stack it follows LIFO principle. LIFO principle is nothing but last in first out. In queues follows enqueue, dequeue, and peak operations, whereas stacks follows push, pop, and peak operations. In queue, only the front element is accessible, but in stack, only the top element is accessible. In queues, insertion are at the rear end and deletion are from the front end. But in stack, insertion are at the top and deletion are at the are from the top. In queue, use for print, queue, and task scheduling. In stack, use for functions call and undo operations. So in queue, we represent queue as defined max size, then we will type define structure, then we will take local variable and store it as items for maximum size and take int f for front and r for rear. But in stack, we will define max size, then obviously takes type def structure in which we can take local variable and store it as items and take int top. So these are the difference between queues and stacks. So There are many applications of queues in real life, such as OS scheduling, customer support, and data packed routine. OS scheduling means operating system uses queues to manage processes efficiently. This ensures that CPU time allocates fairly among all running applications. In customer service, queues help managing incoming requests from clients. This allows support system to address issues in an organized manner while providing response times. Or network routers utilizes queues to handle data packets as they travel across the internet. This process ensures that packets are transmitted in the correct order or without loss. So, in conclusion, we will we will see in conclusion queue definition, types, queues operation, sequential representation, and practical application. So, queues is nothing but linear data structure which follows LIFO principle. Elements are added at the RAM and removed at the back end. Types of queues. Queues can be categorized into simple queue, circular queue, priority queue, and dequeue. Each type is suited for different applications. Operations of queues includes enqueue, which adds an element, and dequeue, which removes element. These operations are essential for managing data flow efficiently. Queues can be represented using arrays or linked lists, each with their own advantage. Understanding these representations is vital for implementing efficient queue operations. Practical applications were queues are essential in computer science for task scheduling and resource management. They play a crucial role in handling asynchronous. Here, thank you for the attention, guys. Bye.